A water level indicator detects and indicates the level of water in an overhead tank and relays the information back to a control panel to indicate whether the tank has a high or low level of water. In this tutorial, I'm going to use the ULN2003 IC to create a simple, inexpensive water level indicator. Using this circuit, you can easily control the wastage of water and electricity. Watch this video for detailed step-by-step instructions on how to build the circuit and to know how this circuit works. Towards the end of the video, I will also discuss whether it's really worth building this circuit. This video is sponsored by PCBWay. PCBWay specializes in manufacturing of very high quality, low volume colored PCBs at a very budgetary price. In addition to standard PCBs, you can also order advanced PCBs, aluminum PCBs, rigid flex PCBs. They also provide PCB assembly and other related services which can meet your need to the greatest extent. For this tutorial, we need one ULN2003 IC, 8 different color LEDs, 8 1 kilo ohm resistors, 1 220 ohm resistor, 1 buzzer, a long ribbon cable, and a breadboard or a custom built PCB. The notch on the top indicates the starting and stopping point of the numberings on the chip. Starting from left to right, going counterclockwise, this is pin number 1 of the IC. On the left hand side, pin number 1 to 7 are the base inputs. On the right hand side, pin number 10 to 16 are the collector outputs. Pin number 9 is the common cathode for flyback diodes required for inductive loads. And pin number 8 is the common emitter shared by all channels of the IC. This pin is typically tied to ground. The IC consists of 7 high voltage, high current, NP and Darlington transistor arrays, each rated at 50 volt, 500 milliamp in a 16-pin DIP package. You can connect the IC directly to a digital logic like Arduino or Raspberry Pi, TTL or 5 volt CMOS device without an external dropping resistor. The ULN2003 is known for its high current and high voltage capacity. The Darlington pairs can be paralleled for higher current output. To know more about this IC, please check out my tutorial number 51, all about ULN2003 IC. The link is in the description below. The circuit is very simple. I have connected 7 LEDs to the 7 out pins of the IC via 1 kilo ohm resistors. On my left are the 7 inputs which are connected to a ribbon cable. The other end of the ribbon is submerged in the water with exposed terminals at various heights to detect the water levels. Along with the 7 wires, there is an 8th wire that stays at the bottom of the tank and is connected to the positive terminal. As the tank starts filling up, the water level rises and a conductive path is created between the positive terminal and the base of the Darlington transistor inside the IC. Hence, a logic high is sent to the input pin of the IC, which leads to the corresponding out pin to go low, lighting up the LEDs one by one, starting from the bottom red to the top green. The bottom red LED indicates lack of water and the top green LED indicates that the tank is 100% full. You can also add a buzzer to the circuit to get an audio indication when the tank is full. If you want to be super funky, you can also add a relay module which can turn on or off the water pump. Before assembling the components on a PCB, let's do a quick test on a breadboard to make sure our logic is working as expected. For this demo, I'm going to fill up a glass with normal tap water. As you can see, the LED indicators go up from bottom red to the top green as I keep filling up the glass. The buzzer starts buzzing when the glass is 100% full. Hence, our circuit is working as expected. So this is how my board looks like in 2D and 3D. If you want to learn how to design a PCB, please check out my tutorial number 45, Transformers PCB Badge. The link is in the description below. Now let's solder all the components to the board. Let's first solder all the resistances to the board. Then let's solder all the LEDs to the board. I am using a 3mm green LED as the power indicator. Next, I'm soldering the IC base to the board. Since I care a lot about my ICs and microcontrollers, I never solder them directly to the board. In case of an IC, I always try to use an IC base, or if a base is not available, I use female pin headers. After soldering the IC base, I'm soldering the buzzer to the board. For my setup, I am only using half a meter long cable, but in a real world scenario, you will definitely need a cable way longer than this. So this is how the final setup looks like. As the water level rises, a conductive path is created between the positive terminal and the base of the Darlington transistors inside the IC. This triggers a logic high at the input pin of the IC, and the corresponding out pin goes low, lighting up the LEDs one by one, starting from the bottom red to the top green. When the glass is 100% full, the top green LED lights up and we hear a noise from the buzzer. To be very frank, I see more disadvantages than advantages of using this IC in building a liquid level indicator. You may have a different opinion, but my opinion is based on the fact that the choice of the probe that will remain submerged in the liquid has to be done very carefully, as they rust, foul and deteriorate due to corrosion and electrolysis, causing the LEDs to slowly fade and finally turn off. Hence the probes need to be cleaned and replaced every 2 to 3 years. The circuit will work well with tap water. However, do not use this with salt water or with any flammable liquid. If in your house you get hard water, there will be salt deposits on the probe and you will have to clean the salt deposits on a regular basis. This circuit will not work if you have a metal tank. Replacing the contact points with something non-corrosive may help, but I will not put my bet on that. Another option is to have large electrodes which will have low impedance even when covered with impurities. I would like to say that the ULN2003 IC is not the best device to use for this application. You might be better using a CMOS buffer or inverter which needs less water conductivity to operate and also gives a more sudden output change as the input voltage rises and falls, along with non-corrosive large electrodes. Thanks again for watching this video. I hope it helps you. If you want to support me, you can subscribe to my channel and watch my other videos. Thanks. See you again in my next video. Bye now.